I don't know if I gave everybody quite enough time to try this on your own, but I'm going to go ahead and get rolling. So thinking back to when we were graphing stuff in chapter 3, that this is actually a skill that's going to carry us through no matter what we're graphing. When we're finding these X and Y intercepts, to find that X-intercept, I'm always doing the same thing, no matter what kind of thing we're graphing. If I'm trying to find the X-intercepts, that always means that I'm setting Y equal to 0. And if I'm finding the Y-intercept, it always means that I'm setting X equal to 0. So let's find our X-intercept first. So when I set Y equal to 0, this equation becomes 0 is equal to 2/3 X minus 6. Thinking about our fraction skills, I have fractions, but I also have an equal sign. So personally, I would choose to multiply everything by 3. You don't have to do that as a first step. I'm just going to choose to do that as my first step. And if I multiply both sides by 3, 3 times 0 is still 0. And when I distribute this 3 in, I'm going to end up with 2x and minus 18. If I add my 18 to both sides, I'll have 18 is equal to 2x and x would be 9. So that means that one of the points on my graph is 9, 0 as an ordered pair. For that X-intercept, the Y-intercept, setting X equal to 0, I'm going to have, as soon as my pen decides to write, maybe that pen doesn't want to write this morning. It's okay, we'll give it a break. Y is equal to 2/3 times 0 minus 6. Well, luckily, 2/3 times 0 is 0, and I'm going to get Y is equal to -6, which gives me the ordered pair as a point of 0, -6. Now I've got everything that I need to graph it, because to graph a line, I really just need 2 points and to draw the line between them. So 9, 0, and I'll label that over here, and 0, -6, I'll label down here. That's 9, 0, that's 0, -6. And I'm going to draw the line, and there we go. Questions about my little refresher on lines? So what we're really going to be talking about today is not graphing lines, but using our skills from chapters 8 and 9. Oh yeah, could you skip the math and just graph it to find the X and Y intercept with the slope? You absolutely could do that for a line, for sure. You could skip the math, graph it carefully to find the X and Y intercepts. I would say that as a general statement, that's probably, for me, that would take me more time than just doing the math. But if that feels more comfortable for you for a line, go for it. That will not work, however, really for anything except a line. So we do want to get used to doing the math to find the X and Y intercepts. Okay, so onward toward parabolas. There are a lot of different ways to approach graphing parabolas, and I am going to show us a couple. And I would say, depending on how we have the information, that's what's going to determine how I would choose to graph a parabola. So we talk about parabolic shape or a parabola. Anything that looks like y equals a quadratic. So I'm going to write this as like ax squared plus bx plus c. Anytime I've got y is equal to something in this quadratic form, I know that's going to have this parabolic shape. our base graph or our parent graph would be y equals x squared. My guess is that most of you know what this looks like, but just in case, let's go ahead and carefully plot y equals x squared to talk about kind of what happens as we're plugging numbers in here. So I'm going to go ahead and just make myself a chart of points of x values and y values. And I'm going to pick some numbers. So let's do -2, -1, 0, 1, and 2. And plug those into this equation to come up with the y values. So when I plug in -2, that's going to be -2 squared, which is +4. If I plug in -1, I've got -1 squared, which is a +1. 0 squared is still 0. 1 squared is 1, and 2 squared is 4. So one of the things we can notice about these parabolic graphs or these parabolas is that we have this symmetry, because when I take the negative number and square it or the positive number and square it, either way I end up with spitting out kind of the same value. So I'm going to go ahead and graph these points. So -2 up 4. -1 is up 1, 0 is at 0, +1 is up 1, +2 is up 4. And if we draw a smooth curve through here, this is kind of our basic shape for any parabola. Now, what's going to happen is there are a couple of things that we use to sort of characterize the parabola. And one of them is this bottom part of the parabola, or if it's flipped over, the top part. We have a special name for this and we call it the vertex. And I would say there are two basic ways that we graph parabolas. We either think about the parent graph and where the vertex has shifted, or we think about finding the X-intercepts to come up with the shape of our parabola. And it's just going to depend how the parabola was given to us, which of those two forms we're going to take. So I'm going to, for a second, talk about that vertex. If we're given the equation for a parabola in a completed square form, meaning something that looks like a perfect square plus or minus a number. So let's say that I had x minus 3 squared plus 1. We sometimes call this the vertex form for a parabola. Because that vertex is going to happen when the x value is whatever makes the part in parentheses equal to 0. So if I take this part in parentheses and I set that equal to 0, I get that x is equal to 3. So that tells me that the x value of the vertex is 3. To get the y value of the vertex, I would then plug the 3 back into the equation and end up with y is equal to 3 minus 3 squared plus 1, or 0 squared plus 1. So when we're in this vertex form, we think about where did the vertex move to? So the vertex has moved 3 to the right and up 1. So I would pick up this whole graph, but shift it 3 to the right. So I'm shifting where the vertex is, 1, 2, 3 to the right and up 1. So I would basically be repeating exactly that same graph, but it would be shifted over here. our sort of general equation for the vertex form is anything that looks like y equals a times, trying to use the same letters the book does, x minus h squared plus k. And in that vertex form, the vertex is at the point h comma k. And this value of a out in front, if a is positive, then we say that the parabola is concave up, which both of these parabolas are concave up. And if a is negative, we say that the parabola is concave down. I'm about to flip the page, so I'm pausing for a second in case we've got questions. Otherwise, I'm going to do some more examples. Dun, dun, dun. Not seeing questions. Come up with more questions. Pause me later. Okay. So if I ask you to sketch a graph of, and now I'm going to give us one, let's say y is equal to 2 times x plus 1 squared minus 5. Okay, so there's a question. I knew there were questions. So if I come back here, this is our general formula for the vertex form. So the h and k in any given equation are actually going to be numbers. So let's do an example and see if that helps to make sense of it. So if I wanted to sketch this graph, first of all, I need to recognize that it's a parabola because I'm going to end up with some sort of x squared piece. And then I'm going to look at that and say, oh, that's in vertex form, because this matches up with something that looks like a times x minus h squared plus k. It doesn't look exactly like that, but I can kind of manipulate it to work out. So we can take this and make it match this exactly. By writing this as x minus -1 squared plus -5. And if we do that, then I can just read off my h is equal to -1 and my k is equal to -5, which would mean that our vertex is at the point -1, -5. And if you don't want to worry about memorizing and manipulating to that exact vertex form, you don't have to, because we can just take that original equation, the y equals 2 times x plus 1 squared minus 5. And if you instead just remember that that part in parentheses that's squared, if we set that equal to 0, we get the x value of the vertex. And when you plug that value back in, you'll get the y value of the vertex. So if I plug that back in, I've got y is equal to 2 times -1 plus 1 squared minus 5. Well, -1 plus 1 is 0. 0 squared is still 0. 2 times 0 is still 0. So I have 0 minus 5. And I get that that y value of the vertex is -5. Personally, I happen to think this is a little bit easier, but it's good to be able to recognize when something is in that vertex form and kind of be able to manipulate it a little bit. Now let's get back to sketching this graph. So to sketch the graph, I'm going to place a point at my vertex. So let me get my graph here. So I'm going to go 1 to the left and then down 5. So there's my vertex down here at -1, -5. And then I'm going to check. The number out in front is a 2. That's positive, which means my parabola should be a concave up shape. And I'm just going to sketch it in. Now, if all I've asked you to do is to just sketch a graph, this is fine. You might also, for some other problem, need to find the X and Y intercepts. But if I've just asked you to sketch a graph, this is all you need to do. So there's a request to go back to talking about the positive negative thing and how that works. So I'll just do it again here. I'm gonna flip the page, but don't need to. Yeah, so there's lots of questions about like what's happening with the positives and negatives in the mix here. So if you're going to rely on this equation, it is annoying, but the part in parentheses has to look like X minus something. The part on the end would need to look like plus something. So that's why if I wanted this to match up with this, I have to kind of manipulate that by turning that positive like backwards into minus a negative and turning that negative kind of backwards into plus a -5. Personally, I think it's easier to just remember, set the part in parentheses equal to 0, and then plug that number in. I don't think it takes a lot more time. Now, in terms of what's going on with that A out in front, if A is positive, then the shape will look like concave up like a cup. That's my attempt at drawing a coffee cup. So if A is positive, we're concave up. And if A is negative, I can spell, then our parabola is concave down like a frown. Dumb, but maybe it'll help you memorize the thing. So let's sketch one that is concave down, just so that you can see what that shape would look like. And I am keeping an eye on the chat, so you can keep throwing more questions at me. But let's sketch a graph of y equals -3 times x minus 2 squared minus 4. Things to notice. If we wanted to just rely on this looking exactly like our vertex form, that -3 tells me it's going to be concave down. This already has that x minus something, so that means h would be a +2. And what's hanging off the back is going to be k, which would be -4. Or we take the stuff in parentheses, set that part equal to 0. We would get the x equals 2, and then we plug it in. I've got 0 squared, which is 0, times the -3, which is still 0, 0 minus 4, is -4. So my vertex is at 2, -4. And that -3 out in front means that we'll be concave down. So when I go to sketch this, I'm going to go to that point 2, -4. And then draw in a concave down parabola. And I know most of you are planning to take pre-calc next quarter. You will spend a lot more time graphing things. This is just a quick overview so that you've seen some of this before. I promise you'll get more opportunity to graph things. But I'm gonna flip the page in a second, so pausing for questions. Sometimes, actually, I'm going to argue most of the time, when you're given the equation of a parabola to sketch, it is not already in vertex form. So if I have y equals x squared minus x minus 6, and this is what I needed to graph, I have two options. One is to complete the square to force it to be in that vertex form. That would be option 1. I'm not going with option 1 though. Personally, I'm going with option 2. Option 2 is that I check to see if it factors. I have selected something such that it should factor. Anyone see what my factors are? Yeah. And looks like that one has to be negative and that one needs to be positive to make that work. So if what I have factors, then what I would do is find the X-intercepts and the Y-intercept, and that's going to let me sketch the graph. So to find those X-intercepts, I'm going to set y equal to 0. I've already got it factored. So that means I know that either x minus 3 is equal to 0 or x plus 2 is equal to 0. And I get two answers. X is 3, x is -2. That is actually already enough for me to sketch this graph, because that same rule applies in terms of whether something is concave up or concave down, whether it's in this sort of a form or that vertex form. The invisible number in front of that x squared is a +1. So I know that this is going to be a concave up parabola. And if I've got those two X-intercepts, -2 and +3, and I know it's concave up, then I can just go ahead and sketch this thing in. Now, I mentioned at the beginning that parabolas always have this symmetry, because when I plug in like the negative version of the thing or the positive version of the thing and square it, we end up in the same place. We sometimes talk about the line of symmetry of a parabola. And that line of symmetry of the parabola runs through the vertex. And it like perfectly splits that parabola in half. Well, the cool thing is that even if it's not in vertex form, we have a quick way to find the vertex, because that vertex should always be the midpoint of the two X-intercepts. So if I have my X-intercepts, then we can find the vertex, or at least the X value of the vertex. We can find the X value of the vertex by looking at the average of the two X-intercepts. Because that's how I would find the number that's in the middle. So 3 plus 2 on top, 3 plus negative 2 on top is going to give me a 1/2. So the X value of my vertex should be 1/2. And if I plug that back in, I could get the Y value for my vertex. And it doesn't actually matter which of them you plug it into. I'm going to plug into the first one. So if I take that 1/2, I'm going to have 1/2 squared minus 1/2 minus 6. Because we are coming up on a final exam, I'm going to let you all mess with the fractions and simplify this to a single term. We live in the common denominators. Should we do it together? So, there is something in the chat that is a really great idea. We just have to do something first. So, thinking about our order of operations, I have to address the fact that this is squared before I think about addition and subtraction of fractions. So that first step has to be to square this out, and 1/2 times 1/2 is 1/4. But you totally could, at this point, multiply both sides by 4 to get rid of the fractions. That is probably not what I would have thought to do, but I like it, so I'm going to do it. We have an equal sign, we have fractions. Why not? Let's multiply both sides by 4. So if I did that, I have 4y on the left-hand side, and over here I have to remember to distribute that 4 through. So 4 times 1/4 is going to leave me with 1. 4 times negative 1/2 would leave me with -2. And 4 times -6 is -24. So I would have 4y is equal to -25. And then at the end, I'd have to divide by the 4 to get the y by itself. So I'd end up with y is equal to -25/4. So my vertex would be at +1/2, -25/4. By the way, if you just got a common denominator on the right-hand side, you should have ended up with the same thing, hopefully. Did anyone do it the other way? And get the -25/4? So even though I didn't ask us to, I want to take this same equation and talk about how we can get that same value for the vertex by completing the square. Oh yeah, I can do it the other way if we didn't think to multiply by 4 and we wanted to just get a common denominator, for sure. So if I was just going directly to common denominator, so I'm kind of backing up to where we had y equals 1/4 -1/2 -6. Well, my common denominator would be 4. So on this one, I would need to multiply by 2/2. And that 6 would need to get multiplied by 4/4. Which means I'd end up with 1/4 -2/4 -24/4. Or 1 - 2 - 24 all over that same denominator of 4. Should get that same thing. So let's go back to this x² minus x minus 6. And put this into vertex form so that hopefully we get the same vertex and we could have graphed the same thing. So just as a reminder on completing the square, it's always helpful when the coefficient on the x term is even because we're going to cut it in half. But even if it's not, we can still complete the square. So I'm going to take that x² minus x. I'm going to scoop my -6 over. We're going to take half of the coefficient on the x, which would be a -1/2. So we'll add in a -1/2 squared and subtract it back off. Which means this part turns into x minus 1/2 whole thing squared. And this part would look like, well, 1/2 squared, -1 squared is +1, and 2 squared is 4. And we're subtracting that thing. So we'll have -1/4 and then -6. So we are almost in that vertex form. We would just have to combine these two numbers at the back to get our k value. And for this, we're going to want to get that common denominator again. So I would multiply the 6 by 4/4. So that this whole thing became y is equal to x minus 1/2 squared minus 25/4. And now it's in that vertex form, and we can grab that vertex off of 1/2 comma -25/4 and say the invisible number out in front is positive. So it would be a concave up parabola with a vertex at 1/2 negative 25/4. And that matches what we've got going on in our graph up above. Dun, dun, dun. I want to get a couple more examples. Seems like usually as soon as I turn the page, questions pop up in the chat. I would say, I think you should practice both. I think you should practice finding the X-intercepts or things that factor, or even if they don't factor, you can use quadratic formula to do that. And you should also practice completing the square. So the reason that this is just going back to how we complete the square, we take half of the coefficient in front of the X term, and half of -1 is -1/2. But let's do another one by completing the square, just for practice. So let's find the vertex by completing the square. And let's say y is equal to x squared plus 6x minus 1. So the last one was a little bit messy because we ended up with fractions, but do you all want to try completing the square on this one on your own? We'll give y'all 2 minutes to try completing the square on that one on your own. So I don't think it's going to factor. I think I intentionally wrote something that doesn't factor. So you have to do the completing the square thing, where we take half of the coefficient on the X terms. So half of that 6 is going to give us 3. So we'll end up with like X plus 3 whole thing squared. Have you done some of the numbers yet? It's okay, we have it. It's not due yet, so it's totally fine if you have it, but we're doing this completing the square thing. Take half of the number. You could get exceptionally clever, but do way more work and use quadratic formula and then like somehow work your way back to completing the square. But I think it would be more gross. So let's walk back through those steps for completing the square. So I'm going to take half of that coefficient, and whatever I get there, that's now I'm saying that this is going to be x squared plus 6x. I take half of what we got and I square it and then subtract that back off. The whole reason I'm doing this part is I don't want to change the original question, right? So I'm adding something and subtracting it back off, which means it's like a net 0. And the reason that I have to square it is so that this piece factors as exactly the same thing twice, essentially, like x plus 3 times x plus 3, or x plus 3 squared. This part at the back, 3 squared, that's going to be 9. So I've got -9 minus 1, or minus 10. So this put our parabola into vertex form. And then I can find the vertex. My preference is to take that part in parentheses, set that equal to 0, and then plug that in to get the y value. So our vertex is at -3, -10. And just as a reminder, that chapter 9 quiz is due on Wednesday. There are problems where I specify that you must use completing the square to solve. If you use a different method, I will not give you points on that problem. So don't ignore completing the square. You have to be able to do this. Also, don't ignore factoring or quadratic formula. On this quiz in particular, I'm specifying which method you have to use to solve the quadratic. We have 5 minutes left. I know I put this in the chat right at the beginning of class, but are there any problems from the homework that anyone would like to see me work through? And I do have office hours this morning over in C class from 10:30 to 11:30. And then I also have my Zoom office hours today from 2 to 3. You can also make individual appointments with me. If you are looking at my appointment calendar and it looks booked for the week, it's probably because I am, but send me an email and I will try to find a time that we can meet, even if it looks like my calendar is full. I'm not seeing questions in the chat. Let's do one more quick example. It'll be quick because I'm already going to give it to us in factored form, I think. But let's find the X and Y intercepts of y equals -5 x plus 8. So this time I'm not asking you for the vertex. We should not try to complete the square because I'm not asking for the vertex. I'm asking for the X and Y intercepts. No matter what kind of function we're working with, we always find the X and Y intercepts the same way. To find the X intercepts, we set Y equal to 0. To find the Y intercepts, we set X equal to 0. And it's always those same two things, no matter what kind of thing we're graphing. So if I set the Y equal to 0, I have two things multiplied together that equal to 0. So that means one of those two things has to be 0. So I've got X equals -8 and X equals +5. Now that means that my intercepts as an ordered pair are 5, 0 and -8, 0. When I go to find the Y-intercept, I'm setting X equal to 0, which means I'm plugging it I'm plugging in 0 everywhere I have an X. So I would have 0 minus 5 times 0 plus 8, or negative 5 times positive 8 should be a negative 40. So as an ordered pair, the X value was 0 and the Y value was negative 40. They didn't ask us to graph this. We could. If I wanted to graph this, I know my Y-intercept is all the way down here at negative 40. I've got X-intercepts at negative 8 and positive 5. And so it must do something kind of like that. By the way, I knew that my vertex was a little bit to the left of the axis because I'm thinking about the fact that that vertex should always be in the middle of those two X-intercepts. And since negative 8 is like further out than positive 5 is, I know it's going to pull everything to the left a little bit. I didn't ask us to graph it. That was just a bonus. It looks like I'm out of time. So I'm going to go ahead and stop the recording.